Alright, it's time to revisit the lost art of long division. This is a Common Core standard for 7th grade, and so what I'm finding is lots of students either did not learn this or it's been so long that they've forgotten the basics of how to set this up correctly and be successful. So we're going to take a quick look at this and help you with that skill. Okay? First of all, we need to understand at a basic level what happens with division, because we no longer really see problems like this with the old-fashioned division sign anymore. We don't see that. But since that's something we all have in common in the past, let's take a look at this and what it looks like as a fraction. Okay? For example, there's what 12 divided by 4, old school, looks like when we change it to a fraction. We can see the first number in the expression becomes the numerator in the fraction. Okay? Now, when the numerator is greater than the denominator, in other words, when the top is more than the bottom, that means you're going to have an answer that is greater than 1. Okay? There's 3 different types of fractions to look at here. We also have, if we flip this upside down, switch spots, we're going to have a denominator that's greater than the numerator. Okay? When that happens, the answer is going to be less than 1. Okay? When the bottom is bigger than the top. And of course, we could also have when they're the same, then that means the answer will equal 1. So we've got 3 different types of answers to look for. It's either going to be equal to 1, greater than 1, or less than 1. Let's take this first example here. Now we can all look at this fraction, 12 divided by 4, and we could think of what the answer is, 3. Excuse me. That's the best type of problem to practice on, is one you already know the answer to. This will help you set the problem up correctly. Okay? Here's a common mistake people make when changing fractions into decimals using long division, is they'll just go like this, right in order. People are thinking, oh, that means 12 divided by 4. Problem is, that's wrong, and it will not work. You can tell it right away because then you ask the question, how many 12s fit into 4? You know it's less than 1. Okay? How many 12s fit into 4? Not very many, right? And that's not what this fraction is saying. Since the numerator is greater than the denominator, we know the answer is going to be greater than 1. So that's just not right. So here's what I'd like you to do when you see a fraction. We already know the answer is 3, by the way. Right? We know that. So let's figure out a way to set this up correctly so we get the right answer. And that is if you ask, how many of these, the denominator, how many denominators fit into the numerator? That's what every fraction is really asking. Every fraction is a question that asks that. So, if we can say this sentence in this order, you just write it in order. You're saying how many of these fit into, and if you actually say the words fit into, when you draw that sign, fit into, then you get everything in the right order. Then we can just simply ask that question, how many 4s fit into 12? Well, 3. We already know the answer. Then we multiply, going this way. Multiply, 3 times 4 is 12. Then we subtract 12 from 12, we get 0. Once we get a 0, we're done. Okay? So if you can use that basic setup for any fraction, you should be successful doing long division. Now let's talk about 3 types of answers you can get here. Okay, how about 2 types? You can have a terminating fraction, 2 types of decimals. It can terminate or stop, or it could not terminate, meaning it repeats. not stop. Okay, makes sense? So let's do a couple of sample problems here. For example, if you get this, 4/5, change it to a decimal. Here's what you do. First you ask the question, how many 5s fit into 4? Then you just say it and write it from left to right. How many 5s fit into 4? Okay. Since we see that the denominator is greater than the numerator down here on our example of 4/5, we know the answer is going to be less than 1, which means we're going to put a decimal in here, carry it up above the bar, throw a few zeros out here for placeholders just to help us keep track of everything, since the answer will be less than 1. Okay, so 0 5s fit into 4, but let's figure out what portion of a 5 fits into 4. So pretend the decimal's not there, and you just say, hey, how many 5s fit into 40? The answer is 8. 8 times 5 is 40. We multiply. We get the answer. We subtract. There's nothing left. That means it terminates. And there's our answer, 8/10. Let's do one that repeats. Okay, how about 5/11? Once again, we're going to ask the question, set it up straight. It's all about just having a system that you know works and then doing that system over and over again. How many 11s fit into 5? Put the decimal, bring it up, throw a few zeros out there for fun, and then ignore the decimal and just say, well, 11 does not fit into 5. Does it fit into 50? And the answer is yes, 4 times. Then we subtract. 50 take away 44 leaves us with 6. Bring down a 0. How many 11s fit into 60? 5 of them. 5 times 11, 55. So we multiplied, right? Subtract. Leaves us with 5. Bring down a 0. And we can keep putting zeros. You can either draw the zeros or just keep bringing them down at this point. How many 11s fit into 50? 4. And now we start to see a pattern happening. 4 times 11 is 44. Subtract. Gives us a 6. Another 0. And now we have this repeating 2-digit decimal. When that happens, you put the repeat sign, which we love this word. It's called the vinculum. Most people just call it a repeat sign. Put the repeat sign over the two numbers that keep repeating, and then get rid of all the extra stuff, because your answer is simply those two numbers that repeat infinitely. Okay? And let me give you one more practice problem, one more example. Let's do 3/8. Okay? Question is, how many 8s fit into 3? Decimal, bring it up, add a few zeros. Hopefully you're getting bored by now. That's a good sign. If you're bored, that means you have a system that you're doing over and over and it works. Okay, you're confident in it. Now we ignore the decimal and we just say how many 8s fit into 3? None. How many 8s fit into 30? 3. 3 times 8, 24. Subtract 24 from 30 gives us a 6. Bring down the 0. How many 8s fit into 60? 7. 7 times 8, 56. Subtract gives us a 4. Bring down a 0. How many 8s fit into 40? Exactly 5. And when you get the 0 going down there, that's your happy face guy. That means you're done. That means it's a terminating fraction. It's not terminating decimal. It's not going to repeat. And so we're done right now. Okay, so there's the basics. Give you a chance to practice with a few practice problems. Here's 3 of them. Just pause the video, do the work, and then restart the video. Go! Welcome back. I hope these problems went well for you. Here's how I would attack these. How many 5s fit into 2? And it's good just to say those words in your head every time. It just gives you a habit, a practice pattern that you know works. Okay, 5 times 4 is 20. We subtract, nothing left. That's the answer. Yay, you got that, right? Okay, next one. How many 12s fit into 7? Kind of working upside down here if you didn't notice. How many 12s fit into 7? When you say it in that order, write it in that order. How many 12s fit into 7? Decimal, a few zeros. Ask the question here, none. How many 12s fit into 70? Well, how about 5? 5 times 12 is 60. We subtract, get 10, bring down a 0. How many 12s fit into 100? 8. 8 times 12 is 96. Subtract, bring down a 0. How many 12s fit into 40? 3. 36. Bring down a 0. And look, it didn't look like a repeating decimal at first, but that is what it turned out to be. This 3 is going to keep repeating. You can see that. We're going to keep getting 40 minus 36 down here. So what you do is you put the repeat sign over the 3, get rid of that one, and circle it. That's it. So the 5, 8 is unique, but then the 3 repeats. That is the correct way to express that answer. And finally, how many 9s fit into 5? 9 times 5 is 45. That's how many 9s fit into 50 if you're ignoring that decimal. Subtract, get a 5, bring down the 0. And at this point, you might start to notice a pattern happening. 5's going on forever, right? So we put the vinculum, love that word. Use it in a Scrabble game if you can. It's awesome. Someone asks you what it is, tell them it's that little bar you put over a decimal when it repeats. Get rid of the extra stuff, because once you put the vinculum there, you should have nothing off to the right, because the vinculum is communicating all of that stuff. There's your answers. Hope you had fun, and I hope this helps you make sense out of the lost art of long division and how to change fractions into decimals. Goodbye.